Thank you for joining me today. We started how to design reinforced concrete columns. As I mentioned before, we have two main types of column, short column and long column. So far, we are working on short column. How to figure out your column is short or long? We have this expression for non-sway without lateral. Based on this expression, if this relationship is satisfied, I can say your column is a short column. If this relationship is not satisfied, unfortunately, your column will be long, and we have to consider the effect of buckling. We will discuss this later. For the short column, we have two main types, tight column and spiral column. The main difference between the two types, how you will provide the transverse reinforcement, the ties, the stirrups. In the first one, which is tight column, the stirrups are separated. They are not continuously. They are not continuous through the height of the column. No, they are provided with an equal spacing. In the second one, no, we have spiral reinforcement, one piece rounded around the vertical reinforcement, like this. We started talking about tight column, and we have a very interesting equation according to ACI. The design axial strength of the column, which is short and tight, equal 0.8 time phi time, all of them, time, all of them, time, 0.8 time phi. So 0.85 F prime C area gross minus area steel plus F yield time area steel. And the phi, according to ACI, for tight short column equal 0.65. I discussed some examples last meeting, but before going into another example, I would like to highlight an information from this slide. According to ACI, we have a range for the percentage of area steel inside the column. Keep in your mind and remember that your column, whatever the shape of this column, rectangular or circular column, we have steel reinforcement inside this column. We have steel reinforcement. Looks like this for the rectangular, or looks like this for the circular column. This area steel has a value called area steel, ST. And the concrete column cross-section has a value equal area gross. If you are trying to get the ratio between the area steel and the area gross, this ratio must be 1% minimum until 8% maximum. This is the meaning of this one. The percentage of steel reinforcement can be between 1% and 8%, no less than 1%, no more than 8%. So if you have a chance to assume your area steel inside a concrete cross-section for the column, make sure you will assume your percentage of area steel something between 1% and 8%. No less than 1%, no more than 8%. This information is very critical. Very critical. Because if your area steel greater than 8%, that means we are in this type of column, composite column, and we will have different design styles. Does that make sense? And we need to provide the minimum required of area steel to make sure your column is safe. So this is the reason why we have minimum percentage, 1%. So if you would like to assume it 1%, that's fine, 2%, that's fine, 3%, 7%, 8%, all of them is correct. Does that make sense? So this is the point I need to highlight. We covered many examples last meeting, that's like this example and this example, and I would like to solve this example with you today. We are not given anything about the column except it's a square, tied, short column. This column is supporting a reaction as a dead load equal 130 kb, and a reaction as a live load equal 180 kb. Before going, I would like to highlight that if you would like to get the total reaction on this column, which is called P ultimate from structural analysis, you have to combine the value of the dead load and the value of reaction of the live load. How? Using the combination equation 1.2 dead load plus 1.6 live load. This is how to combine a value for dead and another value for live, how to combine them together. So, just a second to grab my calculator. So the value of dead load equal 130. The value of live load equal 180. Please pay more attention how to solve this example, because what I'm doing right now will be used in Excel. So please pay more attention. How to combine the dead and the live. So 1.2 times 130 plus 1.6 times 180. I get a total reaction equal 444 kb. This is from structural analysis. How to get this value from structural analysis, how to get the dead load reaction, how to get the live load reaction, we will discuss this using RISA, don't worry. Also, keep in your mind that your P ultimate or can be phi Pn, the design strength of the column, which is equal P ultimate, because this is the minimum we can do, equal 0.8 times phi times 0.85. This is the equation of design. F prime C time area gross of the column minus area steel of the steel reinforcement plus F yield time area steel. Just to clarify this relationship, keep in your mind, based on the design philosophy, we need to make sure that the P ultimate is smaller than or at least equal the design strength of your column. If you would like to start from scratch and to make design from scratch, okay, I can assume P ultimate at least equal the design strength of your column. Does that make sense? So I will assume both of them are equal. Let's start. The left-hand side will equal 444 kb coming from structural analysis, and I will multiply it by 1000 to be in pound, because this reaction is given in kb, equal 0.85 times phi 0.65 time. Keep in your mind, inside this brackets or these brackets, we have two unknowns. Area gross of the column, because I don't know what are the dimensions of the cross section of the column. We have a square column, but I don't know how much the dimensions. And also, I don't know anything about the area steel. So we have two unknowns right now. We have two unknowns. So we have to assume one of them and find the second one. That makes sense because the right side of this equation, of the design equation, has two unknowns. How much area gross of the total cross section of the column? How much area steel will be needed in this column? So one of you will say, okay, I will assume the value of area steel equal as a percentage of area gross. That's fine. We can assume this. But how much? How much percentage we can assume for area steel related to area gross? I give you a range based on the ACI. You have a range, 1% until 8%. You cannot go below 1. You cannot go more than 8. You can be in between. How much? It's up to you as a designer. It's up to you. I will not say you have to take this percentage. No, it's up to you. So for me, for example, I'm going to assume 2%. If Andrew assumed 1%, that's fine. If anybody of you assume 3%, 5%, 6%, all of them are correct. So I can say we have 0.85. If prime C, based on the type of concrete, it's 4,000. Time, area gross, I don't know. I'm looking for area gross. What are the cross-section area of the column? Minus. Area steel, I'm going to remove it and put 0.02 area gross of the column. Does that make sense? Because you assume the area steel equal 2%. 2% means 0.02 area gross. Plus, we still have F yield, 60,000, based on the type of steel, time the value of area steel, which is 0.02 area gross of the concrete cross-section. If you look right now to this equation, you will find yourself have only one unknown, which is area gross of the column. This one, and this one, all of them, one unknown, area gross. So I can find out the required area gross of this column. This area gross will be enough to support this reaction 444 kib on this column. So based on my calculation, I can find it out 0.85 times 4,000 times plus 60,000 times 0.02 times 0.8 times 0.65, and I will divide the right side. I got 188.4 inch square. So I need to provide a square of the cross-section, square cross-section, based on the required, the given information. This square will have an area equal 188.4. Let me do it here. So I need to provide what are the dimensions of this column, which is a square, since the required area gross of this column equal 188.4 inch square. It's very easy. That means if you take a square root for 188.4, because we need to convert this area to square dimensions. If you take the square root, the final will be 13.7 inch. So this dimension of the column must be something 13.7 or more. So I'm gonna assume 814. I'm gonna assume 816. I'm gonna assume 818. I'm gonna assume 820. You have to provide dimensions which is not less than the required, the minimum required. As I mentioned before, your P ultimate must be smaller than or at least equal. So I'm assuming at least equal. But if you increase the dimensions of the column, you will be in this situation, which is smaller than. That makes sense? So this is the minimum. It's wrong to assume it 12. It's wrong. That means you provided dimension less than the required. So I cannot provide dimensions for the column less than 13.7, but I can provide more. More means more safe. So if you assume it's 16 inch by 16 inch, because it's a square, that's fine. Okay? If you assume it's 14, that's fine. We need to assume your dimension to be even number. Don't assume odd number. 15, 13, 17, 19. No, we need them to be odd. Even number. That makes sense? So 14, starting from 14, that's fine. But I assumed it's 16 to be more safe. So the new area gross, because you adjusted your dimension, so we will have area gross new, which is 16 inch by 16 inch. So the new area gross will be 16 by 16. It will be 256 inch square. Remember, you assumed from the beginning that your area steel equal 2% of area gross. Right now, your area gross is 256. So 2% of the new area gross 256 will give you the required area steel, which is 5.12 inch square. Then I need to convert this area steel to how many rebars and what is the size of your rebar. So I'm gonna open my table. We should have a table here. Looks like I don't have it. Okay, you can help me, or I can find it. One moment. We have here tables. Tables. There you go. So if you decided to use number 4, number 5, number 6, let's try number 5. So the area of number 5 is 0.31. 0.31. So I will divide this area still by 0.31. I got 17 rebar. Number 5. Looks like 17 is too much. I'm not sure, but let's try number 6. If I choose number 6 with area steel 0.44, so 5.12 divided by 0.44, it gives me 12. Number 6. Keep in your mind, and this is very important, this number of steel rebar must be integer and must be even number. So I will not accept the 17 number 5. I have to convert it to 18 number 5. This one is good. 12 number 6. Keep in your mind why you need your steel rebars, number of steel rebars to be even number. Because if you provided a number of rebars here, for example, we have 5. You have to provide 5 on the other side. That means your number will be 10, even number. If you provided here 4 rebars, you have to provide here 4 rebars. So the number of rebars here at this face must equal the number of rebars on this face. And the number of rebars on this face must equal the number of rebars on the other face. So if you provided whatever the number, the final number must be even number. Does that make sense? You cannot provide odd number. Odd number means your cross-section will not be symmetric. So the final conclusion, this is up to you. I can provide 18 rebar number 5, and you have to arrange the 18 rebars with equal spacing around the perimeter of this column, or you can provide 12 number 6 around the perimeter. So let's try, we provide 12. I will select 12, number 6. So if you provided 12, I can provide here 5. And here will be 5. And here 1 and another 1. Or we have another arrangement. You can provide here 4. And here 4. So we still have another 4. So we can provide here 2. And we have here another 2. So the total will be 12, number 6. So if you have a problem like this one, and you need to design, because we designed something from scratch, we are only given the reaction from structure analysis, and I will show you how to get this reaction from reason. To start your design, I'm gonna assume my area steel as a percentage of area gross, and you have a range 1 to 8. No less than 1, no more than 8. I can put my numbers, and then the final area gross from this equation will be converted to cross-section dimension. Keep in your mind, if your cross-section is not a square, it's a rectangle, and you have area gross, which equal 188. 188.4. Because the problem saying it's a square. This is the reason why I converted this one to square dimension. But if it's a rectangle, I have to assume one side. For example, I'm gonna assume it 14 inch or 12 inch or 10 inch. The minimum is 10. 10 inch is the minimum. We can assume it 8, but I do prefer to be 10 inch. The minimum dimension of your column is 10 inch. Probably we can assume 8, but I do prefer 10 inch. So I'm gonna assume it's 14. If you would like to get the other dimension, this dimension will equal area gross 188.4 divided by the assumed one dimension, which is 14 inch. I can find out the other dimension. It will be 188.4 divided by 14. I got 13.4. So I'm gonna assume it 14 or 16 or 18. It's up to you. It's up to you, but you have to assume something greater than 13.4. That makes sense? Sometimes the area gross you got 188.4. I need to convert this area gross to a circle because your column is a circular column. In this case, I need to figure out what is the diameter of this column. So keep in your mind, in this case, your area gross will equal by divide 4 times diameter square. I have the value of area gross, 188.4. I have by divide 4, so I can find out the diameter of your column. Your diameter, based on this case, 188.4 divided by divide 4. I got diameter equal 15.5 inch. So I will convert this number to integer number. And if you would like to make it even number, odd number, it doesn't matter because it's a circle. No, it's not a big deal. But I do prefer to be even number. So I'm going to assume it's 16. I'm going to assume it's 18. I'm going to assume it's 20 diameter. That's fine, but something more than 15.5. So keep in your mind, the area gross you got from this design equation can be converted to any shape. Can be converted to square, can be converted to rectangle, can be converted to a circular column based on what is the required shape of your column. Since it's a problem asking for a square, this is the reason why I converted this area gross to square. That makes sense? If you adjusted the dimensions a little bit, that means we will have a new area gross. And you assume the area steel as a percentage of area gross, go ahead and find your area steel. Once you get the required area steel, you need to convert this area steel to how many rebars and what is the size of your rebar. Keep in your mind, the number of rebars must be even number to be arranged in the column in a symmetric shape. If your column is a circular column, maybe the number of rebars can be odd number. That's fine. We can provide 7 rebars, we can provide 9 rebars, we can provide 11 rebars because all of them will be symmetric. No worries. So if you look here, they are 7 rebars. That's fine. That's fine. I can convert the number of rebars to be 7. That's fine. Because the 7 will be arranged around the circumference of the circle. That's fine. Anybody has any question about this example? This example, I consider it very critical, very important because you understand how to design your column from scratch. Anybody has any question regarding this example? Looks good. Let me start another part which is more professional. And I hope if you pay more attention and try it on your laptop at home after our meeting, but just pay attention. Last meeting, we started talking about this. I modeled, not last meeting, but the meeting before on Monday. We modeled this slab on RISA, if you remember. I assumed that this is my origin, this is my Z coordinate, or the axis, this is my X axis, and I started to figure out what are the coordinates of each corner. Do you remember that? So we have 0, 0, we have 10, 0, we have 25, 0, we have 35, 0, we have 50, 0. And then 15, 0, and then 15, 10, and then 25, 10, I'm sorry, 0, 15, 10, 15, 25, 15, 35, 15, 50, 15. This one will be 0, 25, 10, 25, 25, 25, and so on. I will repeat this floor not to focus on slab one more time, but to focus on columns. Let me open RISA. I will launch the demo version. Okay. And I will select what? To create a new column doesn't work. Let me close it and open it one more time. I will click here to create a new floor plan. I will select here concrete floor slab and OK. I will cancel this option to provide uniform spacing of your grid. We don't have uniform spacing, unfortunately, so I will cancel it. I will hide this drawing grid and I'm gonna start to insert my points one by one. 0, 0, then 10, 0, 25, 0, 35, 0, 50, 0. This is the first row. Second row, 0, 15, 10, 15, 25, 15, 35, 15, 50, 15. Next row, 0, 25, 10, 25, 25, 25, 35, 25, 50, 25. Last row will be 0, 45, 10, 45, 25, 45, 35, 45, and then 50, 45. If you did not see your grids or your points, view point label, I can see them. And keep in your mind the location of these points exactly like the location of each corner, of each column, or each corner of this floor plan. Does that make sense? I will start to define my beams. Beams, explicit shape, your depth will be 30 inch, width 16 or 14 or whatever. Then apply, then I'm gonna draw my beams. This is what we learned before. After you are done, I will make escape from the keyboard. I would like to check the render view and the isometric to make sure I draw my beams correctly. Then I go back to plan and remove the render view. Insert, we have columns. You will ask me, hey, I did not design my columns. We can assume them any dimensions right now. I'm not looking for exact design when you are doing analysis. Just assume any cross-section dimension. So assume we have 8 by 8, we have 10 by 10, we have 12 by 12, any dimension. That's fine, 12 by 12. I don't care about this dimension. I need only the reaction. So I don't care about the dimensions of the columns at this moment. Okay. And apply. Then I can put my columns. Your columns at each column. If you would like to see the render view, here is your columns and here is your beams. The last step, insert slabs. Slabs. I'm gonna assume the thickness of this slab 5 inch. Apply or insert slabs. Slabs. Your thickness is 5. Okay. Draw slabs. I will apply for draw slabs. Apply. Then I will click at each corner. In this area, we have stairs, so I will not click there. And there is a start point. Then I can show up the slab. Keep in your mind, assume this floor plan for office building. So if you would like to What? Sorry. Insert loads, area load. Your building is office. So I'm going to select here office. And I will click within the area parameter, apply, just click where you have live load. And then escape. From spreadsheet, make sure you have the required combination. That's fine. Then I can start to solve. We learned all of this stuff last meeting on Monday. I don't care about anything related to the slab or beam. I will focus on columns. I will focus on columns. So keep in your mind, if you open the results, we have here column results. Concrete. Actually, this is not the required results. We will see column forces, not column results, because column results include many things. Column forces, which is a vertical reaction, not column results. I will, to be more specific, the vertical reaction, column forces. I will see this window or this table. We have the name of each column. We have column number 1, column number 2, column number 3, column number 4, and so on. And I have where is the coordinate of each column. So the column number 1 at 0.45. 0.45 means this is the one. Does that make sense? This is the column CS1. This is the name of column CS1. Does that make sense? So this table, how did you get this table one more time? Results, column forces. You will have this column, this table. The first column represents the name. This column represents the coordinates of each column. And this is the base reaction. This is the reaction from there or on each column. This is the reaction dead and the live combined. Dead and the live combined. Does that make sense? 1.2 dead load plus 1.6 live load. This is the final reaction on the column. I will convert this table from RISA to Excel. How can I do this? If you highlight, I need only the first 5 columns. The rest are not important for me. I will highlight the first 4 columns, right click, and we can select export to Excel. One more time. If you would like to import the whole table, that's fine. It's okay. But I do recommend to highlight the first 4 columns, including the name, the coordinate, and the maximum base reaction. Then right click, export to Excel. Okay. You can save them anywhere on the desktop, save, export successful, and the file will be opened automatically for you. Actually, this one export everything in the table, everything exported, not only the first 4, not only the first 4 columns, the whole table was exported. That makes sense? One more time, if you would like, I will remove it. I will highlight the table, right click, export, okay, and you need to save your file and the file will open automatically. Keep in your mind, I don't need all of these columns. So I will highlight them, delete. I don't need this column. I don't need this column. I don't need this column. So I will highlight them from the top, right click, delete. So what do you have right now? Also, I don't need the first column. It's not a big deal. Wait. Looks like we missed something. Yeah, I missed the name of the column. This is not good. So I need the name of the column, which is CS1, CS2, CS3, CS4. I need the coordinate of the column. And then I need the total reaction on each column. I can make it at the center. I can put it at the center. So this is the final. We have 20, I'm sorry, I think we have 2, 4, 5, we have 20 columns. If you look here, we have from CS1 until CS20. We have 20 columns. And these are the coordinates of each column. So for example, column number 11, where? At 0 and 15. 0 in Z, 15 in Y, this is column number 11. That makes sense? Another example, column C17, number 17, at which one? 50, 15. 50 in horizontal direction, 15 in the vertical direction. So this is the one. That makes sense? So I kept the 3 important information. The name of the column, where is this column, and what is the total reaction on this column. Anybody has any question so far? Any question so far? I will start my design, but a little bit, I need to wait a little bit. Do you have any question? Okay, I have question, and please answer my question on the chat. Write your answer. Do you think this reaction, maximum base reaction in KEB, 13.05 on this column, do you think this reaction is the value of P ultimate? The value of P ultimate that will be on the left side of this design equation, or something else? My question one more time. Do you think this reaction, which is coming from RISA, after you analyzed your plan, I have reactions on each column. This reaction should be used in the design. Do you think this reaction will be the left side of your design like we did in this example? I have 1.2 dead load, 1.6 life load. This is your P ultimate. This P ultimate is the value which is coming from RISA. So my question is, this is the value that will be located here or something else? Yes. Your answer is correct, but at the same time is wrong. Yes and no. Yes and no. Why it's wrong? Because if you go back to RISA and hide everything and make sure everything is clear, and if you show up the render view and the isometric, what you did on RISA is only one floor or one story. However, this building is 10 floors or 10 stories. One more time. One more time. This building is consisting of many floors. What do you mean by many floors? I mean, we have many floors. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 floors, 10 building of 10 stories. What you did in Riza, you simulated only one floor. Anybody in this meeting, can you see any more than one floor? It's only one slab with one column or one level column, one floor columns. This should be repeated 10 times in the vertical direction. That means your reaction from Riza, which is P ultimate from Riza, must be multiplied by the number of floors, 10. So this reaction, which is coming from Riza, yes, it's 1.2 dead load plus 1.6 live load, that's fine. But this is only for one reaction. I'm sorry, one floor. One floor. This is what you did on Riza. So I have to set up a new value for P ultimate, a new column equal. I will write equal. This reaction time 10, where 10 is the number of floors. If you are designing building for 5 floors, I will write 5. If you are designing building for 2 floors, I will write 2. If you are designing building of 1 floor, that's enough. This is your P ultimate. I don't need to multiply with any. That makes sense? So just keep it in your mind that what you did on Riza only for 1 floor. The reactions you got from Riza are reactions for 1 floor. If you have multiple floors, I need to multiply this reaction by how many floors in your building. Once you did for the first column, just double click here or just grab it to down. It will be repeated for the whole columns. Does that make sense? So this is your P ultimate and this is your left-hand side. This is the left-hand side of your design equation. Does that make sense? So keep in your mind P ultimate equal 0.8 time phi time 0.85 F prime C time area gross minus area steel plus F yield time area steel. Then close. So P ultimate, we have it right now on Excel. That makes sense? Phi is 0.65. F prime C 4,000. I'm gonna use concrete of 4,000. Area steel, I'm gonna assume it 1%. You can assume it what you want. You can assume what you want, but you have a range 1 to 8. So I'm gonna assume it 1%. F yield based on the type of steel is 60,000. And your area steel is 1% of area gross. If you simplify this equation, I will find myself P ultimate will equal what? 0.85 times 4,000 time area gross minus 0.01 plus 60,000 time 0.01 time 0.65 time 0.8. It will equal 206 2.3 area gross. I just simplify. I have only one unknown area gross on the right side. So the final relationship will equal P ultimate equal 2062.3 area gross. Based on my assumption, area gross 1%, I'm sorry, area steel 1% of area gross, and I'm used concrete 4,000, I'm used this if yield 60,000. If you would like to figure out the required area gross for each column, you have to divide P ultimate after you multiply it by 1,000 to be in pound, divided by 2062.3. That makes sense? This is my next step. I need to figure out the area gross for each column. I will say equal this total reaction P ultimate time 1,000 to be in pound divided by 2062.3. Enter. I got the area gross for the first column. If you grab this column down, I found the area gross for each column just in a second. Do you remember? I spent much time to design this example. I found the area gross for all of these columns in 1 second. Whatever the number of columns, if you have 40, if you have 100 columns for the whole project, I can design them in a very short time. Assume we have rectangular cross section, so I'm gonna assume B to figure out T. I'm gonna assume my B equal 14 inch or 10 inch, for example, 10 inch. So this 10 inch will be the same for all of them. If you have 10 inch, the value of B, keep in your mind and remember, if your cross section is rectangular cross section, and this, the value of B, you assumed it 10 inch, I can find out the second value, which is T, by dividing area gross by B. You can find the value of T. That makes sense? So the value of T will equal this value, area gross, divided by this value of B. Enter. I can find out the T for the whole columns. That makes sense? We expect your T will be decimal number, so I can adjust the value of T. I can convert 6.3 to be 10 because the minimum is 10. 17.4 to be 20 or 18, it's up to you. 16.6 to be 20. 9.10 or 12, it's up to you. And 9 point, the minimum is 10. 9 point something, it will be 12. Be more generous, as I mentioned the last meeting. Be more generous. You are designing a column, and this column is supporting the whole building. We are designing the column at the first floor, supporting the whole building. So be careful and be generous. 17 point something, I will make it 20. 29, it will be 30 or 32. That's fine. 31, it will be 34. 11 will be 14. 7 point something, it will be 10. 5 point something, it will be 10. 14 something, it will be 18. 12 point something, it will be 16. 14 point something, it will be 18. 7 point something, it will be 10. You are a designer, so it's up to you. 14 point something, I will make it 18. 25, I will make it 30. That's fine. 17 point something, I will make it 20. 22, I will make it 24. That's fine. So by the end, I can say column CS1 will be 10 by 10. Column CS5 will be 10 by 10. CS10 will be 10 by 14. column C15 will be 10 by 18. That makes sense? So I almost done. What is the required area steel? Keep in your mind and remember, you assumed your area steel is 1% of the new area gross. So your area steel will be equal 1%, 1 divide 100, time this B time this T adjusted. If you multiply B time T adjusted, you got the area gross adjusted. Enter, and I can grab this cell to the whole column. So I found the required area steel for the whole columns. What is the number of rebars? I will assume that I'm gonna use number 5. The area of number 5, I think, is 0.31. So equal, this is the area steel. If you divided this number or this value by 0.31, I got the required number. Go down. I expect your number will be decimal. So this is the number adjusted. 3 point something, it will be 4. 6 point something, it will be 8. Your number will be integer number and even. 6 point something, it will be 8. 3 point something, it will be 4. 3 something, 4. 3 something, 4. 6 something will be 8. 10 something will be 12. 10 something will be 12. 4 something will be 6. 3 something will be 4. 3 something will be 4. 5 something will be 6. 5 something will be 6. 5 something will be 6. 3 something will be 4. 5 something will be 6. 9 something will be 10 rebars. 6 something will be 8 rebars. 7 something will be 8 rebars. So by the end, I can say, for this rebar, for this column, for example, CS2, where is this column? At 10 and 45, this is the coordinate. The design of this column, 10 by 20, 8 rebars, number 5. This column, for example, column CS number 13, where is this column? At 10 and 0, coordinates. The design of this column is 10 by 18, 6 rebar, number 5. Does that make sense? So if you have many columns, I can design them in a very, very short time using Excel. And the reactions on the column can be exported from RisaFlow. And keep in your mind, the reaction which is coming from RisaFlow is only one floor. So I need to multiply this reaction by how many floors do you have, how many stores in your building. Once you get your P ultimate, you got the right side, the left side of this exam, P ultimate. Then go ahead and assume what you have on the right side. Assume your area steel as a function of area gross. What is the value of F prime C? What is the value of F yield? And then you can keep going to figure out your design. Does that make sense?